As promised, I'm going to work another example linear programming problem. Okay, Brian sells cakes and cobblers. Each cake requires 1.75 cups of sugar, 2 eggs, and 2.5 cups of flour. Each cobbler requires 0.75 cups of sugar, 2 eggs, and 4.5 cups of flour. By the way, this is a ridiculous amount of flour for a cobbler, but I wanted the problem to work out better. In any case, Brian only has 15 cups of sugar, 2 dozen eggs, and 48 cups of flour. We're going to assume that he has all the other ingredients that he needs to make any number of cakes or pies, cobblers that is. We are told to sketch a graph that shows the possible combinations of cakes and cobblers that Brian can make. Okay, so for every linear programming problem, our first question, or our first task, is to define the variables. Obviously, we are going to talk about how many cakes Brian's going to make and how many cobblers Brian is going to make. And so we need to define variables. C seems like a bad choice here because they both start with C. So I'm going to go with K. It even sounds like cake. So K is going to be the number of cakes. And I'm going to choose B for the number of cobblers. So once we've defined the variables, we can begin writing the constraints. The only variables we're going to use when writing our constraints are K and B. Okay? As always, we start with the extremely obvious. Namely, Brian cannot make any less than 0 cakes. So K has to be greater than or equal to 0. Nor can he make any less than 0 cobblers. So B is going to be greater than or equal to 0. Okay. Now, we have to look at the constraints here. There's any number of things that could constrain how many cakes or cobblers you can make. For example, how much time Brian has. But that's not listed here. What we have to go with constraints are what we are told. And we are told that he has a limited amount of sugar and eggs and flour. So for each one of these, I'm going to write a constraint. So let's write the constraint for sugar. Okay, so let's pretend for a second that we had as many eggs as we wanted, as much flour as we wanted. We're just going to talk about sugar. Okay, well, first of all, he's only got 15 cups of sugar. So that's the most sugar he can use. However much he uses is going to be less than or equal to 15. Okay, now the amount of sugar that Brian uses is going to be how much he uses for cakes. I'm going to put that over here. Plus how much he uses for cobblers. I'm going to add it together, and whatever I get is going to be less than 15, or equal to 15. Okay, so how much sugar is he going to use for cake? Well, if he makes 0 cakes, that's 0 cups of sugar. If he makes 1 cake, it's 1.75. If he makes 2 cakes, it's going to be 3.5 cups. If he makes 3, it's going to be, 3 plus 225, 525 cups. Basically, all you have to do is multiply the 175 times the number of cakes that he's going to make. So that's going to be 175 times K. We also have to consider how much sugar he's going to use for cobblers. Well, it's 0.75 times the number of cobblers. Simple as that. Okay, now we're going to consider the next ingredient, eggs. I circled the wrong one. He only has, okay, we'll circle here. He only has 2 dozen eggs. Okay, so let's talk about eggs. We're going to add the amount he uses on cake to the amount he uses on cobbler, and that's going to have to be less than 2 dozen. 2 times 12 is, he's got 24 eggs. Okay, he uses 2 eggs for every cake. So that's 0, 2, 4. Okay, so we're just counting by 2. 2 times the number of cakes, and 2 for each cobbler. That's going to be 2b. And then finally, let's talk about how much flour. He's only got 48 cups of flour. So I'm going to add how much he uses for the cakes, plus how much he uses for the cobbler, and that's going to have to be less than or equal to 48 cups. He's using 2.5 cups for every cake, so that's going to be 2.5 K. For each cobbler, it's going to take 4.5 cups. So 4.5 times B gives us the total number. Let's see if I can graph each one of these. You'll notice that each one of these is in standard form, and so it's going to be easiest to graph by intercepts. All right, so just to be clear, Cakes are going to go on the horizontal axis and cobblers on the vertical axis. All right, let's see how much cake we can make if he made no cobblers. So we're going to ignore this. And we're just, 1.75 equals 15. Well, let's divide 15 by 1.75. And so if all he made were cakes, then he can make about 8.5 cakes. This is not exact, but that's okay. If all he made were cobblers, then we'd let this equal 0. We'd ignore this. Divide by 0.75. 15 divided by 0.75 is 20. He can make it exactly 20 cakes. So once you've got your intercepts, you can get out your line tool and connect the dots. All right, and let's talk about eggs. This one's much easier. If so, two eggs. If you didn't make any cobbler, that means you can make 24 divided by 2. You can make 12 cakes. Similarly, you can make 12 cobblers. You can, on the line tool, you would use a straight edge at this point, a ruler. Okay, and then finally, I'm going to switch back to purple and talk about this right here. Okay, so let's say you made no cobblers, 2.5 cups of flour. So I'm going to divide 48 by 2.5, and let's see how many cakes we can make. 19.2. So approximately 19.2 over here. And what about at 4.5 cups? Okay, how many cobblers could we make? 4.5, 10.66667. So it's 10 2/3. It's about right here. And then I'm going to connect the dots. Okay, in all of these situations, we're going to shade underneath the line. And so when we're done, I'm going to try to be fairly careful here. This is our feasible region. I'm going to thicken this up a little bit to quicken. This is our feasible region. Okay, the prompt, it just tells us to make a graph showing the combinations of cakes and cobblers that you can make, and we've done that. Anywhere in this pink region, in this feasible region, is a combination of cakes and cobblers that Brian could make. Obviously, we would stick with the whole numbers. He's not going to make 2/3 of a cobbler or something like that. But each of the integers works. Now, I'll go ahead and give you, you know where we're going with this. Brian sells these cakes, sells these cobblers, and we want to maximize his profit. And so you know to do that, the max and the min are going to be at the vertices. So let's identify these vertices. Okay, the first, and almost always there, always the easiest, is the origin, 0, 0. That's kind of silly. Although we do know that's going to be the minimum. If Brian makes no cakes, no cobblers, he's going to make no dollars. Okay, and now fortunately, we know here we've got 0, this vertex is 0, 10 point, approximately 10.7, which we're not going to be able to, he wouldn't make, if he made just cobblers, he'd only be able to make 10. Anyway, might need to consider that. I don't know. Okay, so that's one of our vertices. We need to find this point right here, this point right here, and finally this one right here. We already know this one. This was the blue one, and we got, I'm going to have to look it up. Maybe I should write it down. It was 8.57. Approximately. So that's like, he can make 8 cakes. All right. Now, right here, we've got to find where the purple line and the green line cross. So the purple and the green. They're both written over here. I'm going to rewrite them. 2k plus 2b equals 24. I'm not worried about the inequality sign. And then 2.5k and 4.5b equal 48. Okay, what we need to do now is eliminate. So we're going to need to multiply these two equations by numbers that are going to make them so we can eliminate. I'm going to try to eliminate the k's. And I'm going to think of a number that 2.5 and 2 go into. If I count by 2.5, it's 2.5 and then 5, 7.5. And when I get to 10, 2 and 2.5 go into 10. So I'm going to multiply the top equation, everything times 5. So that's going to be 10k plus 10b equals times 5, 120. All right, and then to match it, I'm going to multiply everything in the bottom by negative 4. So I get negative 10k minus 18b equals 192, negative 192. And then we're going to add these up. The k's are eliminated. Negative 8b equals negative 72. And so I know that b equals 9. So the cobbler equals 9. That's right here. Cobbler equals 9. And now I can find the amount of cake by plugging in b. Let's just plug it in right here. So this would be 18. 2k plus 18 equals 24. And then I subtract 18 from both sides, divide by 2, and k equals 3. So maybe we should make 3 cakes and sell 9 cobblers. Let's do some erasing. Now we're going to have to do the same thing for the blue line and the green, blue and the green. Okay, that's the top two here. 1.75k plus 0.75b equals 15. 2k plus 2b equals 24. All right, I think it's going to be, all right, I'm going to count by 1.75, 3.5, plus 1.75 is 5.25. 1.75 again is going to be 7. Okay, so 4 of these make 7. 2 can't go into 7, but if I double that, so if I go all the way up to 8, if I multiply this times 8, it's going to get me up to 14. So if I multiply the top one by 8, I have 14k. Plus, multiply this by 8, I get 6b, equals, multiply that by 8, I get 120. And now, I'm going to need to multiply the bottom one by negative 7. So I get negative 14k, negative 14b, equals negative 140 plus 28, 168. Okay, and now we're going to add. The k's are eliminated. I'm left with negative 8b equals negative 48. I divide by negative 8, and b equals 6. So this point is 6 cobblers, and I'm going to plug b back into, let's plug it into this equation. I'm just going to have 12 plus 12 equals 24. So if b is 6, then k is also 6. All right, we have our vertices, 1, 2, 3, 4, and 5. So I'm going to